In the first part of this lesson, we talked about how to calculate the volume of a rectangular prism. Volume got introduced to you to review, because it's going to come into play today, as the size of the base layer times the number of layers. So in our rectangular prism, our base layer was a rectangle, and we know we find the area of a rectangle by doing length times width. And the number of layers always ends up being the height, which is how we ended up with length times width, because that was the base layer, times height. Today we're going to expand that formula. So this general formula, this idea that volume is the base layer times the number of layers or times the height, can be used to calculate other types of prisms. The thing we have to remember, if we're going to look at prisms that are not rectangular prisms, we have to remember which side of the shape is the base layer, because sometimes the shape might be flipped around. It might be sitting upright, it might be laid down on one of its different faces. So the thing we have to remember when you're working with a shape that's not a rectangular prism. If it's a rectangular prism, it doesn't really matter which side you use as the base layer because they're all rectangles. With other prisms, it does. So if you're going to use a non-rectangular shape, the base layer will always be one of the parallel congruent sides. So we talked about these when we talked about the definition of a prism. So remember, parallel means they're running the same direction, and congruent means they're exactly the same shape. The height is how tall the shape is when you place it with the base layer, when it's placed with the base layer down. So in other words, if you stand it up on it, so it's resting on its base layer, however tall the shape is, that's the height. So you have to be careful with that, because sometimes shapes might not be facing the right direction. So we're going to look at an example to get you thinking about that and get you thinking about how can we use this idea of volume from the first part of the lesson to calculate some other prisms. This diagram that you're looking at, bottom part of your notes, is a triangular prism. We just said that the base layer is always one of the parallel congruent sides. So we have to look for those parallel congruent sides. So in this case, the only two sides that are parallel, that are running the same direction, are right here and here. And they're congruent because they're both triangles, so they're the same sides. So that means that those are the base layer. That also means that this triangular prism is laying down on its side. It's not upright. So if we wanted to put it upright, and this is also a little bit of how to sketch a good prism every time, little math meets art for 2 seconds. We wanted to put it upright. The triangle we done down at the bottom. And here's how you can draw an upright prism. If you draw the shape and then the other congruent shape kind of up above it, and then you can just connect the matching sides. So if it was stood up, not a perfect drawing, but you get the idea, it should actually look like that. So the base layer should actually be resting down on the bottom here, which means that this 14 inches is actually the height of the prism. So you have to be careful, because sometimes your prism might be laying down on its side like this one is. So the base layer is always going to be one of those two parallel congruent sides. So in this case, our base layer is actually this red triangle. So we need to find the area of the base layer. And wow, this writing went kind of topsy-turvy, didn't it? We will fix that really quickly for when we get to that step. So the very first thing we're going to do is figure out the area of that base layer. Since our base layer is a triangle, we need to find the area of a triangle. And remember, we learned a triangle is half of a parallelogram. So we can do base times height for the triangle, but then we're going to have to divide it by 2 because we only want half of the parallelogram. We also have to be careful because this triangle has a bunch of different numbers labeled. So I'm going to take the units off for just a minute because we know we're working in inches. So we'll put the units back on when we're done. So this is an equilateral triangle. It's 5 inches by 5 inches by 5 inches. So this 5 is the base. But those two 5s on the side are not the height. So the height is if you run straight up and down at a right angle to the bottom edge or the base of the triangle. So that means that our height is actually this 4.3. So those are the numbers that we're going to use to get the area of our triangle. So we can go through and we can go ahead and do that. So 5 times 4.3. So that would give us the parallelogram that we would get if we put two of those triangles together. And that gives us an answer of 21.5. But because that is two triangles together, now we have to divide that by 2. So that means that one of these red triangles has an area of 10.75. And we're measuring in inches, so area we would measure in square inches. You can write that as inches squared. So try to get the right units on your area. And we'll also talk about volume units here in just a second too. So that is the bottom layer of this triangle, or this triangular prism. So if we stood it upright, we figured out the height is actually 14 inches. So basically we've got 14 layers of this 10.75 inches. So that's where we have to come back to this and say, okay, the size of the base layer times the number of layers. So we can use this generic volume formula. So instead of being length times width times height, now it's triangle area times height. So 10.75 times 14, because when we stand it upright, our prism is actually 14 inches tall, which gives us an answer of 150.5. Now that is our volume, but let's talk units for just a second. In the last video, you got a visual introduction where I was literally using cubes to model the volume of a rectangular prism. So the idea of volume is basically how many cubic units or how many cubes will fit inside a shape. So since you're literally counting in cubes, your units are what are called cubic units. So we could correctly label volume units two different ways. We could say 150.5, you could write it out, cubic inches, or you could also say 150.5. If you want to use the abbreviation or the shorter way of writing in cubic inches, you could say inches cubed with a little to the power of 3 there. So either of those are correct labels. So I am going to be looking as we kind of track through this unit that you are using correct labels for different types of things you're calculating. So when you're calculating area, you should be using correct area units, square units. When you're calculating volume, you should be using correct volume units, which are cubic units. So our final answer for this prism is 150.5 cubic inches. So it is just a variation of the first part of the lesson. So if we go back to kind of what we started with the first part of the lesson, you can find the volume of any different shape of prism by figuring out the base layer, figuring out the area of the base layer, and just multiplying whatever the area of that base layer is, whatever shape it is, a rectangle, a triangle, you could do other shapes too, times the height. So what you are going to try today is you are going to practice calculating some volumes specifically of triangular prisms for your assignment today, since